So today we will discuss various questions from May 21 session, and let's start today's session with a question from Applications and Interpretation Paper 1 from May 21 session. And then we'll solve a question from paper 2, then question from paper 3, and there will be lots of interaction in between. If you have any question or if you would like to ask anything, please post in the comment box and we will address to that as soon as possible. Okay, so let me share my screen and let's get started. Okay, Rita, can you see my screen?
Yes, Jalaj.
Lovely. Okay, so in MAI paper 1, uh, there are like mixed questions, but none of them is like extended response question, but still there are questions which cover like good marks up to 7-8 marks. So to start with, let's go with this question. This is from May 21, MAIHL paper 1, question number 16. And this question is on Euler's method. So the question reads, a particle P moves in a straight line such that its displacement x at time t, where t is more than equal to 0, is defined by the differential equation x dot, which is actually x component, change in x component of velocity, is x cos t e raised to the power of negative sine t at time t is equal to 0, x is equal to 1 upon e. So it is obviously an initial value problem in differential equation where dx upon dt is given. So your variables are x and t. So by using Euler's method with the steps length of 0.1, find an approximate value for x when t is equal to 0.3. This is a 3 marks question. And part B is by solving the differential equation, find the percentage error in your approximation for x when t is equal to 0.3. And it is worth 5 marks. Now, while solving this question, we will see various approaches, most popular approaches, some classical approaches, and some approaches which are not conventional, but they're still very powerful. So let's get started. So let's try first with the concept of Euler's method. What is Euler's method and how do we use this? So basically, when do we use Euler's method? Sometimes we do not need to solve any equation, any graph, this differential equation. So we can generate or we can approximate the numerical solution of a differential equation without actually solving it. So what we can do is we can find the value of y for a specific x value. So how do we do this? Let me share on my screen here. Okay, so let's say you're given any differential equation. So typically we work for a first order differential equation that looks like dy upon dx is equal to function of x comma y, and usually you are given x naught y naught, means when x value is x naught, y value is y naught. So how do we use Euler's method here? Everyone knows that for Euler method, you would be asked for a specific value of x, like find what is value of y when x is xn. So this kind of question we can easily do with the help of Euler's method. So first thing we do is we check from x naught to xn. How are we moving? So you will always be given one step size here. In this question, this was given 0.1. We usually write it as h is equal to as h. So in this case, h is equal to 0.1. Then we use some iterations for values of x and values of y. So any value of x is always the previous value of x plus the step size. And for the value of y, we use y and plus 1 is the previous value of y plus h times the derivative of the function at the original point, that is x and yn. Now remember, out here we have two variables, x and t. We do not have x and y. So for x and t, how will this look like? So let's get started. So in this question, out here we have been given that x dot is x cosine t and e raised to the power of negative sine t. And the initial value is x is equal to 0 and y is equal to 1 upon e. And h is 0.1, that is the step size. So this we can write as dx upon dt is equal to x cos t divided by e raised to the power of sine t. We can also keep it as e raised to the power of negative sine t in numerator. So that's okay. Now in the examination, what is expected? What all should we show? We have two variables, t and x. So we have to show values of t and the values of x, and it can be shown in a tabular form. So we can show it in a table. What are the values of t? T starts from, if we see here, t starts from 0. Sorry, let me correct it. This is not x and y, this is t and x. So when t is equal to 0, x is equal to 1 upon e. So we start from 0, then we keep moving in a step of 0.1. So 0, 0.1, 0.2, and 0.3. So we will be moving in these steps for the values of t. Now the corresponding value of x, when t is equal to 0, x is equal to 1 upon e. This is given, this has been given. Now when t is equal to 0.1, how do we find value of x? So for this one, we need to know what is dx upon dt at the point, at the previous point. So out here, your point is 0, 1 upon e. So if you look at dy by dx, dx upon dt here, at this point, it will be 1 upon e. Because x value is 1 upon e, so 1 upon e cos t means cos 0 divided by e raised to the power of sine 0. So that makes it cos 0 is 1, sine 0 is 0, e raised to the power of 0 is 1 again. So this is 1 upon e. So the next value of x will be 1 upon e times 0.1 plus the previous value of x, that is 1 upon e. So this will be 1.1 divided by e. So now when t is equal to 0.1 and x is equal to 1.1 over e, what will be the value of dx upon dt? So we'll write this one here. So it will be x is 1.1 upon e, and this will be cosine of x, that is cosine of 0.1 divided by e raised to the power of sine 0.1, and so on and so forth. So I calculated these values, so I would like to write these values here. And when you use the next value of x, the next value of x will be 0.441106, which is actually the previous value of x plus 0.1 times dx upon dt. And the final value at 0.3, this will be 0.476548. So in these small steps, when we move, then we can see that value of x is 0.476548 when t is equal to 0.3. Now, if we revisit the question, this is very important. Sometimes we lose track of what exactly we are doing. So the question is, by using Euler's method with the step size of 0.1, find an approximate value for x when t is equal to 0.3. So this is our approximation for the value of x when t is equal to 0.3. So this we can write as it means value of x when t is equal to 0.3 is equal to 0.47. Now if we need to use this value, we will be using the 6 7 8 decimal places, but since we are writing this as our final answer for part A, it should be rounded off to three significant figures. If stated to 4 5 6, fine. Otherwise we have to express it to three significant figures. So 0.477. I like this number, 0.477. This was number of my bike long ago. Okay, so this is the value of x. So it took us approximately 7-8 minutes. Now, this is, if you see, this was a 3 marks part of question number 2 in AA paper 2. So if we spend 7-8 minutes in a 3 marks question, it is not justified and we won't be able to complete this in time. So let's have a look at another approach. If we use a graphic calculator, how do we do this question with the help of a graphic calculator? So this is the question. Particle P moves along a straight line. Now, how to get this question? It's I can show it to you quickly to those who do not use TI calculator. You close everything. New, there are different kinds of pages. So you can open Note. In the Note, you can copy and paste as if you're doing in OneNote or you're doing in Pages or you're doing in a Microsoft Word. So I just copied it. So Control X is to cut, Control C to copy, Control V to paste. So I have pasted this. This feature is not available in any other computer, but only in TI. So there are some calculators which use the similar commands, but this kind of like detailed, versatile, and like one full package is not available in any other calculator. So this is our question. We will keep it in one of these pages. Now we will open a new page. To open new page, either we can say Control I or we can go through the menu. So if you do Control I, this is how it looks. And if you are here otherwise through Doc, you can go to Insert or New Page. When you say New Page, the similar menu appears. So this time we are going to solve it and see. We were using list. Values of t, values of x, values of dy by dx. So we will add a list and a spreadsheet page, right? What is here? 2. Okay, never mind. So what we can do is I can delete number 2. I don't want this. So let me delete this page first. Yeah, this is my question and I'm solving it here. So the first one, I would like to have my t values. So I'll just label it as t val. And the second one, I would like to have x values. So I'll put as x val. Okay. Now in the first one, if you remember, our question is right here. So we don't have to change the pages or go to the question paper again and again. By using Euler's method with the step size of 0.1. And the initial value is t is equal to 0. So let's start from 0. And the step size is 0.1. So 0 plus 0.1 will be 0.1. Next will be 0.2. Next will be 0.3. So what you can do is you can just select everything and you can pull. Like simple spreadsheet or Excel document or like in any other computer software we do similar way. So these are t values. Now what we are looking is we are looking for the x values. What is the initial value of x? It was 1 divided by e. So initial value when t is equal to 0, value of x was 1 upon e, or say e raised to the power of -1. So you can write here as this as e raised to the power of -1 and enter. So this is the initial value t, this is initial value x. Now there is one more very important thing which we need to use, that is the change, how your variables are changing. And that happens in terms of the derivative. So out here, in this case, what is dx upon dt? This is defined as x cos raised to the power of negative sine t. So we will use a formula here. We will insert a formula, and it's very simple, is equal to. The formula is going to be, in the question it says x cos t. X means these values. So in B1, so I can put a bracket and B1, and cosine. Cosine, you can type cos, but I like to go through this template. So cosine, so cos of t. T means these a values. So cos of a1. Done. I move out of this. Then next will be e raised to the power of negative sine t. So usual e raised to the power of negative t. T is again in A1, so I'll go to A1 and negative A1. And you can put this in a bracket also and enter. So once it is entered, it shows e raised to the power of negative 1 only. And that if you compare it with our work last time when we did this here, this was, yes, it was 1 upon e. When t is 0, x and divided by dx are same. Very good. So let's move on. Now, we need to find the value of y now. Now you see, value of y, we are using iteration. We are not adding a constant term like what we did for t. So we need to define this one also as the previous value of x, which is in b1. So you can just put a b1 in the bracket and plus h times, h is 0.1 here. So 0.1 times dy by dx at the previous point, right? So dy by dx means c1. dy by dx will be c1 at previous point. So I'll just put c1 and enter. So we get 0.4047. Right? And your work is almost over. Now you don't have to write anything. You don't need to define anything. What you will do now, just give some commands, simple commands here. So how do we do this? Just right click and put fill. When you put fill and when you scroll your mouse down, then these fields will be filled by the same formula that we are using before and the iteration. So come down till here and enter. Do you see there is anything here? There is nothing. Why there is nothing? Because we have not filled the third cell. In this third column, there is nothing. That is why these values are missing. But you can see there is a dash. Dash means it is awaited. So now what we do is we do the similar process here, fill. And once you fill values here, you see everything is there now. So the final value is 4765 when t is equal to 0.3. And when you click on this, double click. Okay, never mind. So, oops, what I did. 820. I know, but I did something here. Okay, so no problem. So let me fill it again. And yeah, it's done. So when t is equal to 0.3, it is 4765. And let's see if it is matching with what we did last time. 476548. Yes, it is matching. So either you can use the calculator or you can do it manually. If it comes in paper 1, obviously you will need to do manually. And if it is in paper 2, mind that this method, Euler's method, is there in both in AA and in AI. Okay, so you may need to use calculator. You may have to do it without calculator. So this is how we do. Now another one. Now I would like to show you one more method of doing the same thing.
Jalad, before you move ahead, we have a few of questions in the chat.
Yes, please.
Like Suhasini Rana asks, but we need to define variable h, isn't it? How does system know that h equals to 0.1?
Okay, how does system know that h is equal to 0.1? So, Suhasini, right?
Yeah.
Okay. So, Suhasini, if you see here, out here, when I defined this one, this one, sorry. Yeah. Do you see I wrote here B1 plus 0.1 times C1? So this 0.1 is actually value of H. And this will always be given in the exam. So you will have a numerical value of H. So out here, if you change H 0.1, if H is say 0.005, just make it 0.005. You see, H will not change. The T values will have a progression. They will go in arithmetic progression because you keep adding 0.1. When it comes to in this context, the T values will go in this arithmetic progression. In this context, when we look at the X values, we will have iteration. These X values will depend upon T values and the previous X values. So they will keep changing according to the previous values, but the H value will never change. So we are using H is equal to 0.1 here when we are defining. Does this answer your question?
Yes, Jalaj, she says yes.
Okay, thanks. Any other question?
Yeah, one more. There is one lady, Indrani. She's asking like this can be done using Euler function from Scratchpad also. I think direct Euler function is the feature of CAS.
No, it is not. I'm coming to that. Hold on. I'm coming to that only. That is the next thing we are discussing. So either we do it manually, or we use the spreadsheet, or we can do it directly with the help of a function which who mentioned? Hassan, who mentioned this?
Which?
This
Suhasini asked
Euler's function.
This Indrani ma'am and
Indrani. Okay. So yes, we can use. So that is the next thing we are going to do. So what we do is once we are done with this, we can have a new, we can insert a new page, new calculator page. And don't use Scratchpad. Scratchpad is for like simple basic calculations. If you are doing this simple calculations, how to convert money or how to find some percentage somewhere. Otherwise, use pages and this docs, documents and all these. So this is very effective. And you can, of course, save it later and use it later. So the second one is we can use Euler's function. If you see in the calculator, this open book icon here in this calculator in the rightmost column, if you click on this one, it takes you to the library, or we call it catalog in calculator. So in this catalog, you have all the commands which are available in this calculator. So if you go to Euler's function, so just press E, it will take you to E. So in Euler's function, E, this is eigenvector, eigenvalues, and Euler's. So do you see we have a Euler's function here? So Euler's function is expression, variables, dependent variables, then list of variables, and so on, so forth. So if you give this command to your calculator, in one command, you can find all the values, you can do everything. So what we do is either you can go to the catalog, otherwise you just type EULER in the bracket. So what all you need to put, if you look at this one, Euler, it says Euler expression VAR, DEP VAR, VAR 0, VAR max, moving on, DEP variable 0. So it is in a typical calculator language. So if you simplify, what all you need to put here, first one, you have to put the value of dy by dx. So your expression. The second one will be your independent variable. Independent variable. What is your independent variable? Then after, you have to type what is your dependent variable. Then after, you have to make a list here. So for list, you use these curly brackets, and here you put the initial value, which is X. Not usually we use, and then last value we usually write as XN, then come out of this list. And then the next command for this is the Y value. And then finally, what we have not used so far is the step size, so H. So we put, where is H? H is here. So we put all these values in the formula. It will say error when I enter, because I have not defined any of these things. So it will say error, but still, I would like to go to the next line. That is why I just entered. So this is the one. You have to use expression, independent variable, then your dependent variable, then a list of the values of your independent variable, your start value and your end value, and then Y value. And then finally, you have to put the step size. So for this question, in this context, if you see dx upon dt was x cos t e raised to the power of negative sine t. So what I'll do is I'll just put EULER, Euler. Some educationists call it Euler. So I think everything is correct. As long as you understand what I mean, or I understand what do you mean, it's fine. So this is x times cos t e raised to the power of negative sine t. So you can just write x, and make sure you use times. If you just write x cos t, your calculator will read this as one variable. So x times cosine of t. So for cosine, either you can type, but it's good if you use this one, cos t. For t, you can use t. This is another beauty of Inspire. In other calculators, you have fixed number of variables. You have to use like x, y, z, w, etc. Out here, you can use anything as variable. So practically there are unlimited variables here. You can have all permutations, combination of these a to z, 26. So you can use any of these as variables. So this is cosine of t. Maybe I can put this also in a bracket. I can put this in a bracket, then move out of the bracket, then e raised to the power of e raised to the power e raised to the power of negative sine t. So I'll use this negative, don't use minus. This is for subtraction, this is for coefficient. My students do this often, so I remind them every time. Whenever I use this, I remind them. So it's my habit, so don't mind, please. So t, okay, this one. Now this is your expression, and what is your independent variable here? This is t, so just put t. Now it is fast. Your dependent variable is x, you put x. Now you have to put a list here. So list is out here. Your initial value is 0, and your final value that you're looking at is 0.3. So 0.3. And we come out of this, comma. What is your initial y value? Y value is 1 upon e. So you can go to 1 divided by e, or you can simply write e raised to the power of negative 1. So I'll write 1 upon e. And then finally, my step size is 0.1. So if I put 0.1, and that's all. So I just have to give a command and enter. Once you enter, you get a distribution here. So these are your x values, 0, 0, t values in this context, 0, 0.1, 0.2, 0.3, and these are corresponding x values. Now, if you look at the last value, x value 4765, and if we go back and check with our answer, which we did manually, 0.4765. And also, if you go and see this one out here is 4765. So everything is matching, means our everything here is correct. So there is nothing wrong here. Now, once you are done, sorry.
Jalaj, one quick thing. There was a comment someone had made earlier on about this feature that you just showed on the calculator of the Euler function. It is disabled during the exams. I think that's what the comment that I saw a couple of comments earlier that during the exams in the press to test mode especially, this particular function gets disabled, and that's correct. That's right. It doesn't work during the exam. However, there are other ways to go around it. That is probably why Jala just showed the
Absolutely.
the list spreadsheet. You could also use the notes page and come up with this method. But this option is there. It's there. So when students are using it in the beginning, they are not so used to the calculator. They don't know the different functions. They can use the Euler function, which is directly available. So the comment is correct that during the exams, when you are on the press to test mode, this particular function gets disabled.
Wonderful. Thank you so much for this
Sure.
feedback, and thanks, John.
Yeah.
And so that is why we are using different ways, different methods. So if you feel that in press to test something is not available or disabled, use the next one. So we have different methods, right? So this is how we can use Euler's or Euler's method to estimate. Now, this was part A of the question. So let's quickly look at the next part of the question. It says, by solving the differential equation, find the percentage error in your approximation for x when t is equal to 0.3. So going back to my canvas here. So let's quickly solve it and see how does it work. So this is a simple variable separable, it seems. So this is part B. So dx upon dt is equal to x cos t e raised to the power of negative sine t. So it is a simple variable separable. So I can say dx upon dt is equal to, dx upon x. Dx over x is equal to cos t e raised to the power of negative sine t and dt. And when you integrate, this will be ln x. And in the right hand side, I think we can do it quickly. If you put sine x as u, then cos t, sine t as u, so cos t dt is du, so you get e raised to the power of negative u du. That gives you negative e raised to the power of u. So this will be negative e raised to the power of sine t plus a constant. Now, if you see initially at x is equal to, t is equal to 0, x is equal to 1 upon e. So when you put x is equal to, t is equal to 0, so e raised to the power of, so this is negative 1, so c is equal to 0 actually. Negative 1 is negative 1 plus c, so you get c is equal to 0. So what we see here is ln x is equal to negative e raised to the power of negative sine t. So this is the solution of this linear differential equation. So going back to the question quickly, by solving the differential equation, find the percentage error in your approximation for x when t is equal to 0.3. So when t is equal to 0.3, at t is equal to 0.3, ln x will be negative e raised to the power of negative sine 0.3. And when you calculate this, I solved it and it was coming 0.475141. So when you find the value of x using this, then x will be e raised to the power of 0.475141. And this is approximately ln t is equal to this. Hold on, I think this is the value of x, not value of ln x. Yeah, ln x is this much. So when you find the value of x, x was coming this much, 475141 from this equation. So you could try it in your calculator. You will find it as x is equal to 0.475141. So now it's simple. We are looking for the percentage error. So percentage error is simply like your calculated value minus original over original times 100 or other way. So you can find either overestimation or over approximation, under approximation, and so on and so forth. So this is how we can solve this question. We took lots of time because we used multiple methods. We had lots of discussion. Otherwise, this question in exam, it is worth 8 marks. So within 10 minutes, you can, our students can comfortably do this. Now, moving on with this, now what happens once you close this file? When you close this file, you will see there is a prompt. Do you want to save unsaved document? You may say yes, you may say no. So now what happens here? Let's quickly go back and have a look here. Once again, so, sorry, this one. My mouse says start. Okay, so yeah. So this was a question, and these are the screenshots of what we did so far. This is how we define. Then you use the fill.